Hello friends. So today I am going to discuss some basic packets like functions and concepts. So before getting started on any practical receipts, we will use this some several core mathematical concept and structures and their Python representations. So in this particular, we will the basic numerical type, basic mathematical functions like a trigonometric functions, exponential functions, logarithm functions, and matrices. So matrices the fundamental in the most of computational applications because of connections between the matrices and the solution of system of linear equation. So see here. So first Python numerical types. So there are the different types of the Python numerical types. So first we need to install like a import numpy as a np, import numpy as np, and second import sci pi, import sci pi as sp, science pi as sp, scientific. Okay, now run it. So now it has been imported. So let's start from like a decimal types. So for applications that require decimal digits with accurate arithmetic operations, and we use the decimal type from the decimal module in the Python's standard library. So I am going to like a decimal types means from decimal import DECIMA import decimal DECIMAL, yeah, decimal triple decimal exceptions. So these are there. So in future this is also called like a float, so don't worry. So let's see, just I am taking like a num1 means number 1 will equal to decimal parenthesis like 1 comma 1 and second num2 will equal to decimal 2 comma 663, and we can edit the both decimal numbers. So could I write like a num1 plus num2, and this is I have gotten like a output. So let's see performing these calculations with the float objects give the result like this. So which includes a small error arising from the fact certain number cannot be represented exactly using a finite sum of power 2. So like example, if you write 0.1 has a binary expressions 0.00001 11000011, so which does not terminate. So any floating points representations is this number will therefore carry a smaller error. Note that the argument to a decimal is a given as a string rather than a float. So you can see here just argument of this number we can see like this, but if I put here inside one, and now it becomes look like this, like a string, and you can see here decimal, this is your output. So I hope, so decimal type is the best on like you can say the IBM general decimal as arithmetic specification, so which is an alternative specification for a floating point arithmetic that represent a decimal number exactly by using a power of 10 rather than power of 2. This means that it can be a safely used for calculations in finance where the accumulate the rounding errors would have dire consequences. So decimal format is less memory efficient since it must store a decimal digit rather than binary digits. So from a decimal import get context. So decimal object like a decimal package also provide context object which allow the fine gained control over the precisions like a display and attributes of a decimal objects. So the current context can be accessed using get context function from the decimal module. So the context object returned by get context. So let's see, the has a number of attributes that can be modified here. So from decimal import get context. Decimal import get context. So get context, it has been context, this module has been imported. Now I like to write the some variable like a ctx, like a get context ctx will equal to get context get comment, okay, and parenthesis this way. So number decimals, like if you write like I write here num decimal, like num will equal to decimal and I have already written, so can write like a 1.1, and now I am going to num and writing here 4 times 3 times doesn't matter. So let's see what is your output. So you could see here like this 1.4641, but if you write here ctx dot if you write ctx just get and dot new precision, set a new precision, so pr dot prec will equal to 4 and num and to the power like a 4. So you can see like your output will be like this. So when we set a precision to 4, so rather than the default like a 28, we see the fourth power of 1.1 is a like a rounded to 4 significant figure. So the context can even be set locally by using a local context. So similarly we can write here local context. So from like a from decimal import local context and number decimal as it is. This one with local context as ctx with local context as ctx 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 dot prec will equal to 2. ctx will equal to 2 and in num four so num to the power 4 like a decimal. So let's see and we can see here can num power 4, like you can see, and this one. So this means that the context can be freely modified inside the with block and will return to the default at end. Look like this. Similarly, just let's try here fractions. So just if we are working for means like with the applications and require some accurate representations of integer fractions, so such as when working with the proportions and probabilities, there is a fractions type from the fractions module in the Python standard library. So uses a fraction like a similar, except that typically give the numerator and denominator of the fraction argument. So let's see. I am going to import like a from fractions import fractions. Import fraction. So import capital F means fraction, FRACTION, num will equal to, so we can write like a num will equal to fraction. One or three. So we can write here 1, 3. So similarly we can write 1 and 7. num2 1, 7, and this will be like a num2, and num1 into num2 becomes, so you can write here like a num1 and 1, num2, and what is the output? So let's see. So this will be like a 1 by 21. So this is the fractions. Similarly, we can also take like a 3 variable num3 will equal to fraction like 1 by 8, and you can write like num3. So is it possible to get your answer? Yeah, exactly, you have gotten your answers. So the fraction type simply score the two integers, the numerator and denominator, and the arithmetic is performed using the basic rule for the addition and multiplication of fraction. Next I am going to discuss like a complex. So the complex means Python also has the support for the complex number, including a literal characters to denote the complex units like 1J in code. This might be the different from the idioms for representing the complex unit that you are familiar with from the other sources on the complex number. Most mathematical text will often use the symbol I, like iota, for represent the complex unit. But here, let's see. We can use like a complex so just I write here z will equal to 1 plus 1j and another complex like you write here the z plus 2 z and plus 2. What happened? So let's see the z plus 2. So we have gotten output like this one, 3 plus j, and we similarly we can write the z plus conjugate. If I write here like z dot conjugate, so yeah, conjugate with the parenthesis, so we can get here like a negative value. Jets, this is the conjugated of the imaginary part. So we can do this way. So this is a special complex number where the mathematical functions we can provide here. So I think C math modules of a Python like the standard library. Now the basic math functions appears in the many applications. For example, logarithms can use to scale data that grows exponentially to give a linear data. The exponential function and trigonometric functions are common fixtures when working with the geometric informations. The gamma functions appears combinatorics and Gaussian error functions is important in statistics. But the math modules in the Python standard library provides all the standard mathematical functions along with the common constant and some utility functions, and it can be imported using a following commands like import math. Once it imports, we can use any mathematical functions that are contained in this module. For instance, to find the square root or non-negative numbers, we use squared functions. So let's try import maths. This module, look here, import math, and after that see here math plus sqrt4 math dot sqrt4. Like you have got it. So we are using the squared sqrt functions with the negative argument will raise the value error. If I write here look like this, means if I go here, we have gotten like a value error, but I remove like this one, we didn't get any error. So the square root of negative number is not defined for this squared functions, so which deal only with the real numbers. So the square root is a negative numbers. This will be a complex number, so can be founded using the alternative short function from the CMath modules in the Python standard library. Similarly, the trigonometric functions like a sine, cosine, tangent are available under their common abbreviations sine, cos and tan respectively. So in the math module, the pi constant holds the value of pi, which is approximately 3.1416. So let's try here. Like just I one variable like a theta will equal to pi and divide by 4. So if pi divided by 4, so yes, did I get any error? Pi is not defined. So pi constant holds the value like a pi. So but if you write like a sine math dot a sine like a not a sine, first you let's start a sine and parenthesis like a theta. So theta will equal to pi by 4, so the pi is not defined in these functions. So pi by 4, if you write like a pi by 4, and I am going to derive this one. So this means theta is not defined. Pi is not defined in these circumstances. Similarly, so the trigonometric function sine, so you are using the alternative square. So let's see here. So in the math module, the pi constant holds the value of pi. So math dot sine, math dot tan, and similarly if you write here, because math has been imported, so now it is not locked. So similarly just you can take like a something log term. So math dot log look here, math dot log 10. So you have gotten exact value math log 10. Now if you want to write here math dot log 10 or 10 like a 1. If I write like a math dot sin ASIN and -1, so you have gotten this value. Okay, so the inverse trigonometric functions are the name a cos, a sin, a tan. Okay. So these are the trigonometric value and these are the log functions in the math modules perform logarithm. It has an optional argument to specify this one. So it is also what e, if you write the e, this is the natural logarithm, so e constant it can assess using like a math dot e. Now the math module also contains the functions gamma, which is a gamma functions, and the functions ERF, the Gaussian error function, which is important in statistics. Both of these functions are defined by integers and gamma functions is defined by the integral. So gamma, if you write the gamma s will equal to integration symbol 0 to infinity and t to the power s minus 1 e to the power minus t dt, and then error functions is also defined like a ERF x 2 divided by under root like a pi, and it will start integration symbol 0 to x e to the power minus t square dt. So like this, just if I write here math dot gamma, math dot gamma, and inside like a 5. So I have already gotten gamma functions within a seconds. Similarly, ERF like error functions has been defined to math dot ERF dot ERF like 2. So in addition to standard functions such as the trigonometric functions, logarithms and exponential functions, math module contains the various number of theoretic and combinational functions. These include the functions COMB, Factorial, which are useful in a variety of applications. So the combinations functions called argument like n and k, the number of ways to choose k items from a collection of n without repeats. If the order is not important, like example, picking 1 than 2 is the same as picking 2 than 1. So this number something written like a NC, K the factorial is called the argument n, returns the factorial n factorial. So combinations just I am going to use definition like right here math.comb, and I need to get here like 5 comma 2, 5 comma 2. So we can get like a combination 10. Similarly, if you write a factorial, so math dot factorial, so you can write here factorial like a math dot factorial, math dot factorial, and get a 5 like this. So applying the factorial to the negative number raises the value error, but if you write here the only positive number, so you can get a value. Okay. So applying a factorial is the negative like a value error, the factorial and the n integers means coincide with the value of the gamma functions also. Similarly, math module also contains like a functions returns the greatest common divisors and its argument called GCD. So GCD, the greatest common divisors of A and B, is the largest integer. So such like how do I write the GCD? So GCD we can write here like the math dot GCD, math dot GCD, and if you write here like a 2 comma 4, so you can get output like 2 is the GCD. So there are also the number of functions for a working with the floating point numbers, and the f sum, like a function sum perform the addition on an iterable of numbers and keeps track of the sums. So each steps to reduce the error in the result. This is nicely illustrated by the following example. So nums will equal to, like you can multiply these things. So let's see, nums will equal to 0.1 and will multiply with like a 10, and sum of these nums we can write sum and sum, and you write this variable m. So you could see your answer. Oh sorry, you have written the nums, so I have written here, so I think now I have gotten your answer like a nums. Similarly, math.fsums we have also gotten like the math.fsums, math.fsums, math.8f sums and sums like this. So f sums, I think this one is the norms, not the sums. So nums. Yes. So you can get here the approx value. So the is closed functions like a true, and if the difference between the argument or is smaller than tolerance, and this is especially a useful unit test. And there may be a small variations in the result based on the machine architectures or a data variability. So finally, the floor and cell functions from the math provide the floor and ceiling of their argument. So the floor of a numbers x is the largest integers f with the f less and smaller than x, and ceiling of a x is a smallest integer c with the like x less and equal to c. These functions are useful when converting between the like a float obtained by dividing one number to the another and integers. So the math module contains the functions that are implemented in C and so are much faster than those implemented in Pythons. So this module is a good choice if you need to apply a functions to relatively small collections of numbers. So it is a better to use their equivalent from like a numpy package. So I will already discuss the numpy, so let's see, otherwise I will make the another videos and I will explain very short because I have already described a numpy the very most of the linear algebras formulas I have already, you can see, otherwise I will describe very short way. Okay, so it will be useful like array creations, routines, okay, higher dimensions array, how do I write the higher dimensions arrays, okay, matrices, basic methods and pro is matrix multiplications, determinants and inverse, so system and equations how to clarify. So I will try this one. Thank you for today. I hope it helps everyone.